Hello and welcome friends. In this particular module, let's discuss about the fundamentals of combustion. Under this, we will get introduced to the combustion process, its advantages and disadvantages, principles of siting of plant, the sustainability of the combustion process, the types of the plants and their operation, flue gas pollutants and their control, basics of ash treatment and computation of air requirement for the combustion. As you learn the content, you will be able to explain the basics of the combustion as disposal and energy recovery method, state available design combustion plant alternatives with their operation, and also to compute the air requirement for the combustion. This combustion process is also called as incineration, and it is proven option to deal with municipal solid waste in order to have either it as ultimate disposal or material recovery or energy recovery. This combustion is chemical reaction in which carbon, hydrogen and other elements that are present in the waste combine with the oxygen in the combustion air, which generates the heat. In addition to flue gases as well as ash as the output of the process. In the combustion principle, gas products include the carbon dioxide, carbon monoxide, water, oxygen, as well as oxides of nitrogen in addition to some other pollutants. Usually, for this combustion operation, air than the required, hence excess air is supplied to the incinerator. This is because to ensure the complete mixing as well as complete combustion, and also to regulate operating temperature and control emissions. However, the air requirements will differ with the moisture that is present in the solid waste, the heating values of the waste that we wish to dispose, the kind of a technique that is adopted for the combustion, and such factors. Combustion as a technique has got many advantages. The way I mentioned in our earlier presentations, almost 44% of the plants that are present over the world are combustion plants. Hence, this is proven technology. The waste reduction in this combustion is immediate. The most of the content that is present in the solid waste stream, if segregated, could be reduced to even more than 90% of its original value. The range could be 75% to 90% as far as the weight and volume reduction is concerned. This operation can be done at the generation site. The air discharges can be controlled by having certain cleansing mechanisms. The ash residue is small and usually it is in inert form. There will be requirement of small disposal area. Some of the ash could also be recycled, reused for other purposes. Out of this, what we get is heat, which is used in order to generate the energy. Hence, the cost component associated with the combustion can be offset. The technique as such is very costly. It needs huge capital to invest. Also, in order to facilitate the combustion reaction, there is a need of skilled operations as well as even the operators. This kind of the combustion is not always helpful to dispose all the variety of the waste. Some waste could be having some hazardous nature, some could be explorable, some may not have the incinerable property at all, and hence all the material cannot be incinerated. In addition, some materials may require some supplemental fuel. As we consider some other factors associated with the acceptance of the public, the risk associated with this kind of the combustion due to the waste management practices is imposed rather than it is voluntarily accepted. Also, during the combustion, as it is emitting the flue gases, as it is emitting the particulate, this will be considerably hampering the surroundings, and hence the property value which is existing nearby would be decreased. Also, there is not full faith on the practices observed in the combustion plant, and hence the public may have distrust on the industry who is running such plants or the government policy, and hence, as far as such points are concerned, the public usually don't accept such kind of the technique, and hence there is a disapproval. In order to facilitate the combustion process, there is a necessity to have these three T's balanced, which are time, temperature, and turbulence. And the time is the residence time which is needed to complete the oxidation reaction in the incinerator, which depends partly on the rate of the reactions at the prevailing temperature and partly on the mixing of the waste stream and the hot combustion gases from the burner or burners. Second T, which is temperature. Higher the temperature, it will cause faster the oxidation reaction to proceed. And third T is turbulence. Here, proper mixing is important in combustion process in order to facilitate the proper supply of oxygen, which is enter air, in order to facilitate the complete combustion, as well as neat exposure of the surface in order to receive this higher temperature in order to ensure the faster oxidation. Hence, one is expected to attend these three T very carefully in order to ensure the complete combustion of the municipal solid waste. In principle, about 65 to 80% of the energy content of the organic matter can be recovered as heat energy, which can be further utilized in order to generate the electricity. However, the kind of the waste that we will be proposing to burn in such kind of the facility must have at least 1450 energy value throughout the seasons. Also, this annual average must not be less than 1700 kilocalorie per kg. The such kind of energy value will depend on the composition of the waste, its density, the moisture content, as well as the presence of inert that are present in the waste. As you consider the typical Indian situation, in order to have the combustion to be self-sustaining operation, the moisture should be less than 50%, the volatile content should be more than 40%, as well as certain inert content should be less than this 50%. So as we consider the real conditions associated with the kind of the waste being generated in India, it is lying in this zone. So really speaking, the waste which is generated is not having the necessary parameters in order to have this combustion chosen as sustainable operation. Hence, the heterogeneous nature of MSW requires this waste to energy system to be carefully designed to operate efficiently over the wide range of waste input conditions. There is a necessity to have the high energy contents separated from the low energy contents, to reduce the non-combustible contents and enhance the volatile combustible contents, so that the combustion reaction will be fully sustainable. The siting of incineration plant, because of the disapproval of the people, is also one of the important tasks. In addition to public approval, this siting should always be determined with respect to economic as well as environmental considerations. So some key factors can be considered as underlined here. The facility must be able to cater, first of all, the need of the management of the waste in that particular zone. As it manages the load of the waste being received, the outputs which are being generated in the form of residues, usually bed and fly ash, must be disposed through well operated landfills, and such landfill site must be available within the vicinity of such kind of the plants. Also, the kind of the facility that we wish to develop, it should be away from the residential zone, and it must be forming part and parcel of industrial zones, so that the availability of other infrastructure could be easily availed for such kind of the plants. Also, the kind of the outputs that are being received, say it could be energy, see it could be fly ash, even certain flue gases. So here these things, if are to be recirculated, reused for certain facility, it's better to have these kind of the sites meant for incineration plant in the near vicinity. As we discussed few of the things associated with the combustion systems, it's very clear to us that through the combustion we wish to ensure the complete destruction, as well as we wish to ensure the minimum emission of the pollutants such as particulate, dioxins and furans in the atmosphere. So keeping this as the basic requirements, one can go for variety of combustion types. Most widely used and technically proven incineration technologies are mass burn incinerators and RDF incinerators. Also, some of the technologies are being employed currently, but their potential use seems to be highly demanding in the near future are modular incinerators and fluidized bed incinerators. In this mass burn facility, minimal processing is given to the solid waste before it is placed in the charging hopper of the system. We are studying this kind of the facility in principle as a facility. It does not mean that this is suitable for the places where the waste is not having essential parameters the way we discussed on previous slides. So here the waste would be received as it is, it would be stored, it would be mixed, it will be charged to the hoppers, it would be burned into the boilers, heat would be generated, the steam would be used in order to run the turbines, and in turn the power will be generated. During the burning, the ash produced as well as fume gases being emitted needs further cleaning. Also, the heat which is generated can be recycled in order to process the kind of the waste that is required to be burned as, say, preheating mechanism. There are some issues associated with this kind of the facility. There would be emission of variety of the air pollutants. As there is not strict control on the kind of the input which is the feeding material, the ash could be hazardous in nature. Hence, the disposal of ash and other byproducts could be questionable. The emissions would be causing the disturbance to the biological resources. In order to have the hot water further cooled, there will be requirement of the large quantities of the cooling water. As the waste is being received and as the ash needs to be further transported at the disposal facilities, in addition there could be impact of the transportation, and the way we discussed about the public acceptance, it is always an issue because one is expected to deal with environment as a whole, as one is expected to tackle with ash, flue gases and such associated environmental impact. As we see here, this is the flow diagram associated with the mass fired incineration. So here the waste is received. As you see here, the waste is combusted, the steam is generated, it is used in steam turbines in order to generate the electricity. The flue gases are moved through the air pollution control mechanisms, it is cleaned and then it is let out into the atmosphere through the stacks. Also, the fly ash getting emitted through the stacks would be likely to be emitted through these stacks would be caught through ASP's filter-like mechanism, and accordingly here this captured would be either recircular or used for some beneficial purposes. This mass-fired incinerator system usually employ the moving grid systems. However, the grid systems could be moving or it could also be stationary, which can be employed for the variety of incinerators. The second facility is refuse derived fuel incineration. The most of the processes that we discussed are valid for the earlier incinerator. Here, the only difference being the facility itself, as it receives the waste, some of the waste could be separated, which is beneficial in nature, and it could be transformed into the powdery or pelleted RDF, which would be used as fuel in the incineration operation. So that way, there is good control over the incinerating operations and the perceived advantages are obvious as contrast to the environmental impacts that we discussed as far as the mass firings are concerned. The modular incinerator is one of the important incinerators because it has got limited capacity, and such kind of the incinerator can easily be employed on the smaller sites where the waste could be generated to the tune of 5 to 120 metric tons per day at say certain housing complexes or small institutional establishments. As we consider the mass fire system or as we consider the RDF incinerators, that systems are very huge. Such kind of systems could be using the working hours of almost 11 months over the year. They have capacity to incinerate the waste of around 35 metric tons per hour, and even some facilities which are established in Singapore like place by Mitsubishi has got capacity to deal with 4,500 metric tons per day. So that mass fired systems or the idea based systems are advantages where the regional incinerator establishment is required. These modular incinerators hence has got advantage because it can work with small facilities, and even there could be small modular units. So 1 to 4 units could be say replicated in order to deal with small communities, these commercial establishments and even the industrial operations. The system as such could be easily installed as we are establishing the control over the kind of the waste. The pollution control could also be established, and here the incineration operation is taking place in 2 stages. The first stage is primary chamber, in which the waste is heated and combusted primarily, whereas in the secondary chamber it ensures the complete combustion, which could be again say requiring some additional feed, and such superheated heat can be used for various purposes. Also, the residue that is being generated after burning could be tackled easily, being the quantity small and as the controls are easier. Other important technology is fluidized bed incinerator. It is a bed of solid particles with gas flowing through the bed to give an expanded suspended mass that behaves like fluid. Here, the grate is replaced by bed of limestone or sand that can withstand very high temperatures. This fluidized vessel is comprising a gas distributor below the bed, a fluidized bed section, and a prebo section above the bed for disengaging the bed particles from the fluid gas. Also, the solid discharge is drawing the solid materials from below the bed. The material is constantly drawn from the bottom of the bed and classified to recover the sand. The smaller particles are returned to the bed with the larger items including glass, ceramic and metals which are rejected as bottom ash. These kind of the incinerators are very consistent as far as their operation is concerned as compared to other technologies. Also, they have higher energy conversion efficiency as well as less polluting potential. Hence, this fluidized bed incinerator is more promising technology as compared to mass fired systems or RDF fired systems. As we consider the variety of the plants, by some or other extents, each of them is emitting the flue gas pollutants. Usually these emissions are really significant since 1 ton of this municipal solid waste produces huge volume of the flue gases. Based on the certain studies, it can be seen that the emissions are 4,500 to 6,000 normal meter cube per ton at 11% of the oxygen. Depending on the technology, operating conditions and the composition of the waste incinerated, there would be diverse pollutants and emitted in this flue gas. So there would be huge distribution, broad range of the particulate which needs to be controlled through the cyclone, ESPs, certain baghouses. There would be acids and other gases which need certain cleansing mechanisms. Also, the heavy metals and carbon components will be in need of certain specific treatments. As we consider this kind of the pollutants, it is necessary to establish the control on that kind of the pollutants in the view of protecting the environment. The ton of solid waste creates around 3.5 megawatt of energy which powers around 70 homes. Usually, the biogenic portion of the waste is considered to be CO2 neutral because the tree consumes more carbon dioxide through its life cycle as compared to the carbon dioxide emitted during its combustion. In order to have this particular environment protected, the particulate matter is controlled through the electrostatic precipitators, fabric filters, and certain gravid bed filters. The oxides of the nitrogen, oxides of the sulfur, and other gases in the form of say carbon monoxide, hydrocarbons, and such things need the source separation as well as combustion control, and also the flue gas treatment in order to protect the environment. There could be certain non-criteria pollutants for which again there is a need of source separation. Also to establish the control on the combustion as well as particulate. Usually this kind of the control is achieved by making use of continuously monitored systems. So such kind of electronic systems will be measuring various emissions and accordingly immediate measures can be taken in order to have their emission brought to acceptable level. As we discussed earlier, the ash is getting generated through the burnings as bottom ash. So through the grates it can be collected separately. As well, some gases as they emit out and as they move with a high speed, they will be having the load of the particulate and that would be nothing but the fly ash. So both these particular ashes needs to be collected, captured and used and disposed so that they won't cause any environmental impact. So usually this particular ash is treated the way this particular flow chart shows. So the ash would be collected, conveyed, it will be screened, it could be washed. Certain coarser contents would be separated. The coarser content which is having the size more than 50 millimeters would be passed through the magnetic conveyors so as to have the ferrous metals removed. Even the non-ferrous metals would be removed through that and the remaining content will be transferred to the burners. The content which is lesser than 50 millimeters would be passed through the washer contents. Further it would be dried. The light organic fraction which is having the size less than 50 millimeters would be further moved to the great incinerators, whereas the residues would be passing through number of such screenings in order to extract ferrous as well as the non-ferrous metals, and also the content which are having to say 2 to 50 millimeter granules can be used for the beneficial purposes such as construction fields, road industry. It can be employed through that land filling daily covers. One can go for the cement block production and also it is useful for treatment of acid mine drainages. The hazardous content needs the further treatment and it must be disposed in the landfill which is specially made for that by following certain specific processes. So the air requirement is very basic process because in addition to that 3 T's, time, temperature and turbulence, the role of oxygen is such vital that otherwise the combustion is just impossible. So as we go for these particular basic reactions and as we consider the air containing 23% of the oxygen, here for carbon, for its combustion, there will be requirement of 11.52 kg per kg of carbon. Similarly, here there will be requirement of 34.56 kg of the air per kg of hydrogen. As far as the total configuration is concerned, we have to consider the net available hydrogen. It will be percentage of the hydrogen minus 1/8 of the oxygen. So H minus O by 8, the way we considered about the characterization, is also to be considered as far as the actual air computations are concerned. For sulfur, there will be requirement of 4.31 kg per kg of sulfur. So this is the basic information which would be required in order to determine the air requirement for complete oxidation. Let's assume that this is some configuration of the West, which is C50H100 O40N. So as we consider the molecular masses, it comes to be 1354 for the kind of the configuration that we have assumed here. So percentage wise distribution of the elements can be worked out as C 44.31, H 7.4, O 47.3 and N as 1.03%. This H minus O by 8 comes to be 1.49% in order to work out the net available hydrogen. Hence, as we have the data which is worked out per kg of each individual element that can be used here, and the net quantity of the air required for 100 kg for the given configuration can be worked out. Hence, it is converted into the ton of waste. So, thanks for your attention, friends. We have discussed the basics of combustion processing, which could be used as one of the important techniques in order to have the ultimate disposal of municipal solid waste as well as the product and also the energy recovery. So as we move ahead, we will discuss about the material and the heat balance for the combustion of municipal solid waste. So by till then, I wish you very happy learning. Thank you.